Hello everyone. In the last video, we just designed our network. Um, Now we have the direct connectivity between the all ports here inside the data center, site 1, site 2, and also in the core network in the NPLS, AS, BGP 65000. Today we are going to configure, in this video, we are going to configure layer 2 configuration in this tree switch in data center. But before starting that, let me explain some more about this network. As you see, we have a data center here, and these three sites is going to receive the access from services from the data center. And in the future video, I'm going to connect the internet to data center, maybe here, and this three sites should be able to access the internet from data center, and also maybe some other expand the network and make some DNVPN here, and also some other services like COCM, Call Manager, DNS and DHCP, email server, and some other services. Let me see what services I can configure in this computer. I'm not sure if my computer is support, but if it is, I'm going to configure the Cisco Firepower 6 with FMC to access and filter the internet to this network. For now, let's start our configuration by configuring the trunk between these ports, between these switches. Okay, let's start from switch 4. Okay, we have 3 ports here that should be trunk. Let's select them in the range 0, 1, 1, 0, 2, 1. Switchboard trunk encapsulation. Okay, in the encapsulation we have 2 options to select our trunk. The first one is .1Q. .1Q, as you know, it's an open standard protocol for trunking, and it sends the information on tag in VLAN 1. It means VLAN 1 never tag, but other VLANs will be tagged with the relevant VLAN number. The second one is ISL, and ISL is a Cisco protocol, and the last one is negotiate. Negotiate means it will negotiate with the other side. If other side is the trunk, it will it's .1Q, it goes to become .1Q, and if it is ISL, it will configure itself as a ISL. Now I'm going to configure the .1Q here. .1Q and switchboard mode trunk. Now let's do the same configuration in switch 5 also. It is range E 0, 1, E1021, switchboard trunk encapsulation, .1Q and switchboard mode trunk. Okay, let's set this on configuration. Switch 10. We only have 2 interface to be trunk. Conf T. Interface is 0, 1, 2. Interface range. Switchboard trunk encapsulation .1Q and switchboard mode trunk. Okay, now trunk is configured between these 3 switches. Before I go for spanning tree, let me configure the ether channel between these 2 switches. As we have 2 ports connected here, I think it's a very good situation to configure the ether channel between these 2. Why not? For the configuration of ether channel, we need to go to the interface range as 1021. A channel group. We need to give a number for this channel group, and between 1 to 255, and as it says switch 4 and switch 5, let's select the number of 45. And now we need to select the mode of our interchannel. We have two modes actually here, the LACP and PACP. LACP is a open standard protocol, and the PACP is a Cisco proprietary protocol. And now I'm going to use the LACP here, and the LACP has two options. It can be active, it can be passive. If I select active, it means this switch is actively send the interchannel information to other side, and if it's be passive, it means it just it doesn't send any information of interchannel. It's just waiting to receive information from other side, and after receiving the information, it will communicate with the other side. Now let's for switch 4, let's select active. Data channel is configured. Let's configure it in the other side also. In the other side, I'm going to select passive 1021 channel group 45 mode passive. In the passive now, it doesn't send any information to other side, but it's just waiting to receive the interchannel information from switch 4. And when it receives, you see that it's give the information, the LACP, and now the line protocol is up. Let's check this port that we configured. Do show interface port channel 45. Show run. Let's show run to this information. You see, it's already configured as a trunk. It means that it inherits the information of the physical port and makes this interchannel port as a trunk. It should be same here. To show run interface port channel 45. Yes. Okay. The interchannel is configured. Now we have trunk between these three switch, and also a trunk interchannel between switch 4 and switch 5. Next, let's configure VTP actually. VTP to make to synchronize the VLAN between these three switch. Do show VLAN. Let's see the VLAN here. We only have two VLAN, VLAN 1 and VLAN 8. Let's create the VLAN first. VLAN, we have VLAN 10 and VLAN 20. This two VLAN is used for the actual data inside the data center. I'm going to connect some services to VLAN 10 and some to VLAN 20. Now VLAN 30, we'll speak about that later. I have some plan for that. In the next video we'll see. And VLAN, we have a connection between router 8 and switch 4, and this connection is with VLAN 8, and also R9 and switch 5 also in VLAN 9, and let's make a VLAN 99 for any other unused ports. Okay, this VLAN is created. Then let's make a VTP configuration. VTP mode server. I'm going to make a switch 4 as a server. You know, by default all the VTP are in the server mode. You see device is already in VTP server mode. By default all of them is in server mode, but we can change that. The server, it means that if you see the option that we have here, the client, server and transparent, and the server means it sends all information to other switches, and client means it doesn't send information, and doesn't mean no, not send information. It means it just wait for the server and update its VLAN database according to the server information. It means it locally we cannot configure any VLAN in the client part. And also the transparent, it means it just pass the VLAN information to other switches and doesn't make change any and doesn't make change on its own database. Now we just select server here and VTP domain. Let's make a domain here, Cisco. Okay, save it. Let's go to switch 5. In switch 5, same VTP mode. In this switch, I'm going to make it as a client to just receive the VLAN information, and VTP and domain Cisco. Do right, and let's go to switch 10 and configure the same. VTP mode client, and VTP domain Cisco. Do right. Okay, let's see. Do show VLAN. You see that the VLAN is already created here, and I'm sure it should be here also. Do show VLAN. Yes, the VLAN is actually the VLAN is created in switch 4 and is synchronized with the database of VLAN 5 and VLAN 6, VLAN 5 and VLAN 10, switch 5 and switch 10, and these two switch actually receive the information of VLAN from switch 4. Okay, now let's configure the spanning tree. Spanning tree is very important in a layer 2 protocol. To selecting a spanning tree protocol, we have different spanning tree protocol here, and selecting the best one according to our requirement inside the network. Let's see what option that we have. Spanning tree mode. We have MST. It's the multiple spanning tree. It is very useful. It will be very useful for big networks with a lot of switches and complex connectivity, because we can make different instances of spanning tree, and in every instance we can actually make route and backup route for VLANs. And PVST is the old version of Rapid PVST. According to the timing, the PVST is a little bit slow for converge, and Rapid PVST is the newer version of the PVST, and it's if you see the name, it's rapid, it's very fast to converge. We just select it as a Rapid PVST, and now let's select the VLANs to be root. Actually select the VLAN to become switch 4 become root for them, and the backup route for others. Okay, and now you have to say sure. Okay, now let's configure our VLAN to switch 4 be the root bridge for them. As you see in the design, the R8 is connected directly to switch 4, then VLAN 8 should be root bridge. Sorry, the switch 4 should be root bridge for VLAN 8, and switch 5 should be root bridge for VLAN 9. Let's see the VLAN that it's available here. Do show VLAN. I'm going to make it spanning tree VLAN. Let's make VLAN 1, VLAN 8, VLAN 10, VLAN 30 as a switch 4 should be root for this 4 VLAN. And the priority here you see from 0 to this big number 6144 and with the incremental of 4096. Priority less means better, means if we select less priority means that this switch will be root for this this 4 VLANs. Okay, the priority of this should be 0, and the spanning tree VLAN for other VLANs like VLAN 9 and VLAN 20 and VLAN 99 4 VLAN left 9 and VLAN 9 VLAN 20 and VLAN 99 and priority for this should be an increment of this. I'm selecting the 4096 to make sure that it will always remain same. Okay, now let's go to switch 4 and do the same configuration but in the reverse. First spanning tree mode rapid PVST and let's copy and paste this from here. Spanning tree for this VLAN, the priority should be 4096. It means it will be backup. It will be a backup route, and for this 4 VLANs, make it 0. Now, if we check the spanning tree here, show spanning tree, for example, for VLAN 8. You see in VLAN 8 we have this switch 4 is a breach, is a root breach, and if we check it for VLAN 9, VLAN 9 is a backup, and bridge ID is this IP, this MAC address. It means it should be switch 4.5. Let's check that one also. Show spanning tree VLAN 8 for VLAN 8. This is a backup, and for VLAN 9 it should be root bridge. Yes, this is the root bridge. Okay, it should be correct for all other VLANs also. Now we configure, let's see, we configure the trunk here, ether channel here, and spanning tree here. Any other configuration that is required? No. Let's configure, okay, we didn't finish our configuration in switch 10 for spanning tree. Here we just need to select spanning tree mode, PVST. It doesn't need to make any changes in the priority in VLANs. Okay. Now let's configure the active standby between switch 4 and switch 5. For that, we have two VLANs here actually. Do show IP interface brief. Show IP interface brief. We have VLAN 10 and VLAN 20 here. And you see the IP address. As switch 4 was a root bridge for VLAN 10, I'm going to make it active in switch 10. Quantity for the active standby, one switch can be active for all VLANs or for some VLANs, and be passive for all VLANs and also for some VLANs. In this case, I'm just going to configure VLAN 10 active in switch 4 and be passive, not passive, standby in switch 5, and for VLAN 20 it should be a standby, switch 4 will be a standby, and switch 5 will be active. Okay, let's go to the interface VLAN 10 with command standby, and the standby is a group number. As it's VLAN 10, I'm going to select standby 10. Then IP, and we need to assign IP address, and this IP address should be in the range of VLAN 10. 192.168.4.1 as a gateway, and standby 10, we need to give a priority as we want this switch be active. I'm going to give a higher priority compared to switch 5. I'm going to give a priority of 110. And the next command, we are going to, when the, for example, switch 4 is now active, and if switch 4 is go down, the switch 5 will become active, and when switch 4 comes back, in this case switch 5 will remain active, and unless the switch 5 become restart or go down, then switch 4 will be active for that. Because I want switch 4 always be active for VLAN 10, I'm going to configure the preempt command here. And preempt means that every time the switch 4 will start, when it come back, it should preempt to become active for this VLAN. Okay, now let's go for switch 5. In switch 5, same configuration, but different priority. Conf interface VLAN 10, standby group, standby 10 IP 192.168.4.1, standby 10. The priority for this one, for that one was 110. For this one, I'm going to put 100, and there is no need to preempt because it's the less priority and it cannot preempt to become active. Now let's check. Let's first ping, between the VLAN. You see that the VLAN 10 in group 10 state speak to standby, and switch 4 should be active. Show standby brief. Yes, the active is local 4, and the priority is 1110. And if we see it here, show standby brief. Come on, show standby brief. And for VLAN 10, this switch is standby, and active is switch 4. Okay, let's configure the same for VLAN 20. Conf bus. This time switch 4 should be standby. Interface VLAN 20. Standby group. Standby, let's select group 20 for this, and IP address 192.168.40.1. And standby priority for this one is 100. Now switch 4 will be active here. Let's wait for that. Let's see if the interfaces are up. It will show interface brief. VLAN 20 is up here. Here we will show interface brief. Okay, this one is down. Okay, interface VLAN 20. More down. Okay, as you see, because we don't have any configuration here in switch 5, switch 4 from standby become active. And if I configure that here, it should be passive, and switch 5 should go for active. Interface, we are already interface, standby 20 IP 192.168.40.1. And for this one, I'm going to give the priority of 110. And if I don't write the command preempt here, switch 4 will remain active unless it become down to then switch 5 will become active. And if now if I enter the command preempt here, you see it is the standby, because it doesn't preempt to become active. Even the priority number is more than priority number here, because it doesn't preempt to become active. Now if I enter the command preempt, you will see in a moment, yes, the standby from standby become active, and this one from active to speak, and now become standby. Yes, now the switch 4 becomes standby for VLAN 20. Okay, we have different protocol for active standby. It's HSRP, VRRP, and GLBP. HSRP and VRRP, these two is from Cisco, and GLBP is open standard. there is not much difference between VRRP and HSRP, but GLBP is a little bit complex, not complex actually. Um, it's will be used in very big networks to the GLBP provides some load balancing also to design a network, a complex network using the GLBP to load balance the VLANs and traffic inside the switches. But for our network here, as we only have two switch and simple design, we just use the HSRP here. Okay, in the next video, I'm going to configure the OSPF in the data center. Our data center will be the OSPF area 0, and if we have time, I will configure the EIGRP in site 1, site 2, and site 3. Thank you for your watching, and if you have any question, please let me know. And also if I made any mistake, because you know that it's a network and it's very wide actually. It's need a lot of information. If I made any mistake, please let me know in the comment, and I will be so happy to learn from you guys. Thank you for watching. Please subscribe our channel, and hope see you again. Have a nice day. Bye.